Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about range extended electric vehicles or REEV. So let's dive deep into it. So what exactly is the problem? Well, problem on a fundamental level, it will not change based on the technology, is that battery does not get lighter as you use it up. Meaning, no matter which technology you're talking about, you could be talking about lead acid battery, you could be talking about nickel metal hybrid batteries, or you could be talking about lithium ion batteries, or whatever else have you. They will always be range limited. Meaning, every country generally has some regulations on the vehicles. For example, your car should not be 55 tons, right? So there has to be some reason and logic to things. Meaning, no matter what you do, there will always be an upper limit of how far your cars can go. Now, there is two ways of solving that issue. A, you make it as efficient as possible, which fundamentally means have as small battery as possible. But again, so you see those things are counteracting. Or other thing, try to just give as big of a battery as possible. But there will always be range limited. Meaning, generally said like we cannot actually cross that 500-kilometer barrier reliably. Meaning, on paper, on dyno, your electric vehicle should touch that. It's just that in real world driving condition, good luck. So it's one of those things. It's a law of physics level. It cannot be bypassed. It cannot be breached. So that's a fundamental problem. And big batteries, right? So we started electric vehicles. People don't even remember back in the old days, we had electric vehicles that had only 15 units of battery. 15 units as in 15 kilowatt hour. Then we went to 30. We're like, whoa. Right now, even Indian electric vehicle manufacturers are like 75. And there are other like pickup trucks, they are going up to 200 unit battery. I'm like, holy damn. Because here's the deal. Physics, engineering, economics. Bigger the battery, higher the cost. Nobody can afford it. And on top of that, you will be like, okay, what can we do to mitigate this problem? The first thing you will come to mind is like, what if we have small battery, but we have ultra fast charging? Yes, still, you cannot do that because again, that is also very costly. And if you reached a point where it's like, I have this ultra fast charging station, but it costs same as petrol in order to use it, because again, the moment you calculate the cost for a remote location fast charging, you'll be like, yeah, I'm using petrol. So that's the whole point. It's too goddamn costly. And here's the ironic part of it. While every Tom, Dick and Harry does want range, but if you compare that, no matter which country you're looking at, be it European Union, India, be it America, you'll always find a parallel distribution to it. Meaning, majority of the oomph, the actual movement of your engine generally happens in the very short trips. For example, why do most people buy their cars? Generally, there is a very good flow curve in lifespan where it's like, oh, you got a job, you got a vehicle. Why? Well, so you can go from your place of habitat to your workplace. Or if you have a family man, you could be like, okay, I will take my kids to school, bring them from school, bring them to some practice coaching centers or some malls or whatever have you. So those sort of jobs, so to say, drive is majority of your car's workload. Meaning most of the time, 24-hour day cycle, you rarely cross 100 kilometer. Meaning, if you can charge 100 kilometer range in overnight scenario, meaning you are sleeping for 4 to 6 hours and your vehicle can easily charge in that time and you can get range of 100 kilometers, 99% of the time you will not have an issue. But we cannot make a vehicle that has only 100 kilometer of electric range. Why? Well, we do need range sometimes. For example, my Espresso that I drive, it's a very simple car. Barely drifts, I barely drive it 10 kilometer, 20. If I'm going to pick up someone in an airport that is far, so that may take 20 kilometer, 10 plus, 10 minus. So you get the point. Most of the time, that's not an issue. I can easily buy electric car and have fun, no longer have to worry about petrol cost. But when I have court case dates, I have to travel 440 kilometers in one day. Yeah, EV is not gonna do that, bro. It's not going to do that. So that is a serious point. And I'm not rich enough where it's like I have one for daily driving, one for long trip driving. I'm not that rich. Majority of people are not that rich. That's why we have to solve the range issue. Now, all this problem that I'm talking about, take this problem, multiply it by 1,000 when you are talking about large vehicle, meaning you are going from cars to trucks. This problem becomes stupid. Meaning trucks are so bad in terms of this problem that governments all around the world actually have to create a rule amendment in order to allow your countries to basically destroy their own roads, because they have to allow more heavier axles. Again, every vehicle has a limit, and if you force an electric vehicle to follow that limit, problem would be the payload mass goes down drastically. They're like, yeah, we can't carry normal standard shipping container because if we do that, our axle loading crosses it. So they have to allow leeway into that, meaning your bridges, your roads, all of them wear down much quicker. So this is a very fundamental issue. Okay, so we have a problem. So is there a solution? Thankfully, yes. So smaller the battery, higher the efficiency. What does that mean? That simply means if you have electric motor and drive train equipment, everything, basically you have a car. If the battery is smaller, let's say instead of 75 unit or 100 unit battery, you shrink it down to, let's say, 15 or 20, the kilowatt hour per kilometer goes up, meaning sometimes you can travel very high distance with only few units of electricity, meaning if this kilowatt hour per kilometer is the target practice, basically same you have miles per gallon or liters per kilometer, same thing goes here, kilowatt hour per kilometer. So you want this number to be as good as possible. You want your vehicle to travel multiple kilometers only on 1 or 2 unit. Again, that's idealistic, but if you make a vehicle heavier, this number goes down. So this number is the target spot. And this number loves small battery. You are like, hey, I have 50 unit batteries. Like, no, no, no. I have 35. It's like, hey. It's like, I have 25. Damn. So you want this number to be as high as possible. So majority of the time, and it has double benefit. Not only it's efficient and meaning you're paying less for electricity, it's also good for environment, because again, inherently you are not requiring more energy just to move. If my ass is like, let's say 70 kg, 70 kg, you're not moving megawatts of energy just to move me here and there. You want this number to be as close to zero as possible. But again, that's ideal scenario. Now, another aspect is because we are so detached from ICE engine, and again, we hate it nowadays, we kind of forget that ICE engines are featherweight in contrast. Like, trust me when I say this, ICE engines are damn lightweight, meaning you're like, okay, what if I add a range extender? Wouldn't it add so much mass and weight? No. Like, you would be shocked how high density ICE engines can be made. And I'm not talking some exotic F1 technology. F1 technology will be like, bruh, I can do this in my sleep. But like, we can do commercial engines that are very lightweight, very high density power, super lightweight, easy peasy. So what does this mean? The solution is very simple. You do majority of your work on EV, meaning you do not have to worry about your fuel cost. You do not have to worry about, most of the time, you do not have to worry about what's happening. But when you do need that, you got auxiliary power, meaning you no longer is like, okay, I'm driving, hey, I run out of charge, I forgot to charge it, or I have some issue where I have to travel very long distance. You keep driving. The car is like, I got you, fam. I got you. The car is like, uses a fuel-based generator, be it petrol, be it diesel or CNG, compressed natural gas, which is just methane, majority methane. Or some scenario, somebody was smoking, they were thinking, what if we use hydrogen? I'm like, why? Or sometimes hydrogen internal combustion engine. Why? But you could do that. Again, I will also selling that. I'll talk more about that. But if you are stupid enough, I'll sell you. So fuel-based system, that's the backup system, meaning you have your electric system, majority of the time you use that, you do not even think about other things, and when you do need that, you do not even worry about it. Just like keep driving. Your car is like, bruh, your battery is running low. It's like, nah, I have to keep driving. It's like, okay, starting the auxiliary power unit. So it does that, and it allows mass adoption without risk of grid collapse, meaning, which again, right now everybody is facing, everybody who has electric only, they're like, oh, in a fire scenario, my vehicle becomes a trapped paperweight. Oh, not too good. So trust me. And not to mention, it's like, oh, I'm gonna have fast charging, like, Elon Musk, Elon truck, have fast charging. It's like, have you seen how remote those petrol pumps are? Like how much wiring you have to do, high voltage transmission line, and I do not think that will be done in 33 kV. It has to be done at 135 kV. Yeah, that will cost millions of dollars per kilometer. Good luck. So grid load will not be there, and no range anxiety. You do not have to worry about it. It's like, hey, I have a car, I'm driving the car, and car goes where I can go. And again, when I get tired, I just stand out, go into a petrol pump, refuel the car, and voila. I don't have to think about it, do not have to change it, anything change. And smaller battery has two core benefits. First, lower cost, meaning people can actually afford the damn thing. Another, low CO2 footprint, meaning if you are an environmentalist, you should not be happy with the ideas like, what if we had 200 unit hour battery? I'm like, holy damn, you do not want to look how much emissions happen because of that. It would be much better, economical, environmentally friendly. Instead of, let's say, 100 unit battery in per vehicle, you only had 33 in 3 vehicles. That would be far efficient. And ICE can be more efficient also, because you're like, hey, I bought an internal combustion engine, and it said on paper it will give you 22 km per liter, whatever the number may be. 22 it will give me. I drive it, I tested it, and it's only giving me 18 or something like that. That's my real life experience. Now here's the deal. That's not somebody cheating you, that's penalty of real life. Meaning, if engine, if you have to compare the efficiency of the engine, you cannot compare based on miles per gallon or kilometers per liter. You have to compare on brake specific fuel consumption. meaning you know how much chemical energy is there in the fuel. If you can figure out how much crank is getting out of it, there you have the actual efficiency that is measured by BSFC. And BSFC has the benefit that it does not care about engine sizes, meaning if I tell you 10 kilometer per liter, that may sound a very horrible car, but if it's a 10 kilometer per liter or diesel locomotive, they're like, this is magic technology. The same thing. That's why BSFC, it's a independent number, meaning it does not give a damn about your size. It only gives a damn about your basically efficiency, thermodynamic efficiency. And all engines, whichever manufacturer, be it CAT, be it Scania, be it whatever have you, Fiat engines, they all have this three-dimensional curve to it, meaning they have RPMs, they have torque, and they have conversion efficiency. And there is a sweet spot at the right RPM, at the right torque, not just only RPM. RPM is one factor. You have to control the second also. If you have the right loading on the engine and right RPM, you're going to get the maximum conversion efficiency. You can even see that if your car has a real-time mileage. Sometimes it will give you a very high number. That simply means the engine crossed that island, efficiency island. It's just nigh impossible to keep the engine there. Why? It's real life. You have wind pushing you against you, side by loading, uploading, accelerating, decelerating, all of those things makes it nigh impossible. And that's the job of gearbox, trying its best to keep you in the sweet spot. It's nigh impossible. But even if you do parallel hybrid, you can do it much more efficiently. If you do series hybrid, you do not even have to worry about it. It's like, bro, I'm floating. So you will get far more energy per liter of fuel, even if the engine technology is the same, because you are floating it. So your BSFC would be actually utilized. It's like, engineer, I worked my ass off to make this puppy 35% efficient. You're like, I utilize it at 35% efficient. So that's the solution. So let's look at the first solution that humanity tried. That was stupid. Parallel hybrid. Now, parallel hybrid basically means you have two power rails, basically your wheels and your power sources. One is battery, one is fuel. And you have two pathways, meaning if your battery system goes kaput, no problem, it's a combustion car, don't think about it. If you run out of fuel, kaput, don't worry about it, you have a battery system. So it's a dual pathway. Basically, energy can go from either from basically motor to the wheels, or it can go from transmission, basically engine transmission to the wheel. So you have to. Now, why does everybody loves this? Well, everybody loves this because marketing people, they get orgasm out of it. Why? This puppy has double power burst, meaning if let's say you look into this Honda vehicle, okay, everything is cool. It's a normal city vehicle. It has 50 horsepower combustion engine, 50 horsepower electrical system. Here's the deal. What the marketing people will do is like, they know, sir, people want to feel the acceleration. It's like, it's a 50 horsepower system, but how will you make them feel like 100? Trigger both of them in parallel. Rev the engine, basically. That's why you get the knobs when you have like eco mode and sports mode. You tell sports mode is like, oh, the man is feeling rich now. Okay, engine, go YOLO. Electric motor, go YOLO. Both of them going YOLO at the same time means you will feel the oomph. And that's the same reason why F1 has kinetic energy recovery system. It gives you the oomph. And those puppies have like 160 horsepower, this size. So it does allow that. That's a very sweet thing to sell to people. It's like, horsepower without actually having the horsepower, because it's a burst load. It cannot sustain it, and even if you tricked it to sustain it, it will self-destruct. It's not designed to withstand that load. So that's the whole point. Double power burst, super awesome. And it does give you full isolation, meaning if your internal combustion system is bricked, no problem. If your EV is bricked, no problem. You do not have to worry about it. However, this is anti-engineering technology because this puppy has high complexity. And here's the deal. You have to pay for that complexity. It's not just, oh, it's complex, who cares? No, you have to pay for it. You have to pay for it. This gentleman, amazing. You want to understand electric vehicles and hybrid drivetrains? Watch this gentleman. I have linked the video down below. And in few of his video, you will learn more than enough. More than enough. You'll like, I got this. Look at this box, man. It has a generator, motor generator unit, another motor generator unit, and the gearbox that looks like, if you want to give yourself a brain damage, try to understand that. And again, let me be very clear. I'm talking facetiously, but it is complex. It has way too high parts count. And you're supposed to add that on top of an ICE engine, which already has ludicrously high parts count. So it becomes very high, complexity engine. And on top of that, ICE engine does not like this idea. ICE engines are not meant to be like, turning on or off. Once you turn it on, they do like to be like getting up to warmer temperature, and they're like staying there. They do not like, I'm running, oh, stop. I'm running, stop. I'm running, stop. you will destroy your engine. Majority of your engine wear only happens at the starting cycle, and if you are doing start stop often, you will brick your engine. That same engine that could be like, I am time tested engine, I have served this company for 25 years, I am 1 million mile engine, and you put it in this parallel hybrid system, and they're bricking itself at 50,000 kilometers. Like, what the hell happened? Yeah, engines do not like frequent start stop. They are not meant for that, because one of the biggest issue again for people living in northern areas is that it has cold run issue, meaning it likes to stay at one temperature. So everything expands to one ideal temperature. And what about overheating? That's why you have radiators, so it does not over expand. So there is a sweet spot. It goes to that sweet spot, it stays in the sweet spot, and you're good. Everything is nice. Everything is sunshine and rainbows. But if you start and stop, the temperature will expand, contract too much, wearing out to kill it. Now again, it will not break your engine. It will not destroy it instantly. But over time, it will drag down very extensively. You're like, the engine should last 100 million miles. It won't. So that's the problem, like again, thermal problem. Another aspect which again I just recently find out, yeah, your oil does not like this. I'm like, why? Well, oil supposed to be at above 100 degrees Celsius. If it's not at 100 degrees Celsius, there will be too much water in it. I'm like, where the hell people are injecting water into their oils? Then I'm like, oh, your fuel is water. It's CH. So for example, it's a CNG system, CH4. There is water there, hydrogen is there. What are you doing? You're taking the hydrogen, you're going boom boom to it with oxygen. What is the output of that boom boom? It's water, CM, basically CO2, that's carbon dioxide, and H2O, water. You have piston with a sliding ring, which is, again, it cannot be absolutely sealed because it will not move. So some amount leaks through the crank area. And penalty of that is, there is water. So carbon dioxide, water, bad. Water condenses, water goes into the oil, bad things happen. And again, that's why your engine, when it starts, it tries to warm it up. And again, even the radiator will not kick on unless everything reaches to a certain point. In a hybrid, it's like, what are you doing? I'm not even joking. They had to build a new oil formulation just to make sure the engine does not self-destruct as quickly as possible. Penalty, you have to pay higher prices for the oil and for the car and for the servicing. Yeah. That's why, even though we had this technology for almost 30 years, you would say, yeah, this has not picked up for this exact reason. Complexity is the enemy of reliability and your wallet. So this is a very dumb idea. Again, people like it in F1 because again, F1 has no budget. But you have to understand, for city driving cars, not good. So we come to the range extender, the finally wisdom that people are understanding is that series hybrid drivetrain. Now, what does that mean? That simply means your vehicle is an EV vehicle first. It's a battery vehicle. That's it. The end is nothing else. You cannot have a combustion engine going to a gearbox, then driving the wheels. No, it's an electric vehicle first, with onboard a generator, meaning you have a way of generating electricity when you are out of battery power. That's it, nothing more. It will only give you range. It will not give you horsepower. It will only give you range. So that's there. Now, you have two limit ranges here, meaning let's say your electric axle, let's say e-axle are consuming 500 kilowatts, and you're like, okay, I want generator to 500 kilowatt. That's one option, right? That's one option. Or other option would be like, let's say something like this Mazda unit. You could be like, hey, I have 250 horsepower. It's like, electric motor is like super fast, but my range extender, it's a small compact unit, only gives you 150. Like, why would you want it smaller than that? Here's the, you're not supposed to run on range extenders. These are the option, these are the variables. If the people who are doing the market studies, they realize majority of the time people will not even turn on their range extender, why add the weight and bulk of those things? It's just have that. And benefit of having range extender rather than not having it is that you will never be stuck. You will be uncomfortable, but you will not be stuck. Meaning if you are driving this puppy in, let's say, Autobahn, you're going pedal to the metal, going all in, all YOLO. The moment battery power runs out, the car will say, hey, it's like, sir, sir, relax, sir. Again, it can keep driving and to reasonable speed also, but it's like, yeah, sir, please go to slow lane now. It's like, slowly let us charge, or you park it and let it charge. So that's the penalty. Now, again, more than enough for 99.99% of the times. Don't even think about it. But for if you're doing for truck, yeah, that sort of scenario is that's not acceptable. At that point, your generator would be almost matching the same output, or sometimes even more. So you can, let's say, at full load, you're going YOLO on the highway, carrying heavy load like 60-ton load, and you're like, okay, I'm driving full and batteries are fully depleted. You turn on the generator is like, I got this. It's driving and charging the battery. Again, if you want that, it's not recommended, but you could do that. So you have that range, equal to EV or smaller than EV. Most of the time, smaller than EV is more than good enough for majority of humanity. Now, it does not give you that double power burst, that's a penalty, but it gives you KISS. All the engineers, write it down. What does that mean? So What's the benefit of this drivetrain topology? It's time tested, meaning anytime they, oh, it will not work. It's like, brah, this thing has been tested with submarines for a century, diesel locomotive for a century. Yes, I double checked it. It's a century old now. So yeah, this is the only way of doing it. That's why diesel locomotives have 3,000 horsepower. Do you think there is a gearbox that can handle that? Those planetary gears for ultra planetary with this extra planetary? No. 3,000 horsepower running an alternator. Done. Go home. Sweet dreams. Done. So that's the core benefit of it. It's a very time tested, very robust. Again, I cannot tell you more robust things than these puppies. And it's elegant, meaning the parts count go down. Meaning if your company is mass producing it, they won't be like, oh, we have like, variable valve timing system and variable piston length system. Yes, somehow somebody is designing that also. And all that, it's like, throw all of that away. Throw that. Just yeet that away. Make an engine whose basically efficiency is as high as possible at the RPM you design it to. Like, that's it. There is no gearbox, there is no variability, there is no adaptability. Just convert the liquid fuel to electrical energy as efficiently as possible, the end. And it does not even have, quick start and stop, because it will start, it will slowly ramp up, and then it will stay there at least for 15 to 20 minutes. It won't go, wing. So it's very elegant. Parts counts is lower, lifespan is higher, time-tested designs. So it's very, and there is another benefit for people who want luxury. It has no physical path for noise and vibration, because when you have gearbox connecting to the wheels, you have a physical path of that engine directly transmitting to yourself. Now we do our best to suppress it, but what if it was floating? Meaning you inherently cannot sense it. Why? Because it's floating. Every contact point is floating. There is no mechanical connection there. There is no, drive shaft or something like that. Everything is floating. Again, you may say, how would you float the fuel tank? Again, fuel tank would be smaller, but you may require some flexible hosing. I think humanity has figured out that technology, and electrical wires inherently flexible. So everything would be flex floating, and you're going to have much quieter experience. You may not even figure out, it's like, hey, wait a minute, why my engine? Oh, my engine is around. So it's like very subtle. You can just like isolate the hell out of it. As long as you have good radiator. That's the penalty. The radiator has to be a bit bigger. So because again, it may be designed to a scenario where it's like you could be standing still and engine is going all out. So radiator has to be a bit bigger. That's the penalty. But we're good. We got this. We got the technology. So range extra is the only viable solution without bankrupting the companies that are building it or the citizenry who's buying it. So what can we expect in the future? Now, thankfully, there has a lot of renewed interest in internal combustion engine now, like a lot of new interest. I was shocked, like the amount of money, the amount of new companies claiming they have new ideas. I'm like, what is happening? Well, drone warfare happened. Basically, Russia went boom boom with Ukraine, and Shahid drones became a very, very interesting point, and people are like, I need an engine to do that now. So lot of interest, like so many drones that are like, hybrid drivetrain drone. I'm like, damn, that happened. On top of that, people have learned the hard way that things that people should have known 20 years ago is like, yeah, you cannot run these hybrid system, because once they break, the amount of money you have to spend in order to repair that is like, throw this thing away. Like, that's why, please watch that channel. It's like, see how much hard work it is just to tear it down. Compare that to an Edison Motors truck. A truck is easier to tear down, easier to repair, easier to service, because it's a series hybrid system rather than those EXL and ECVT. It's like, holy damn. So world is going back to the scenario. It's like, hey, petrol prices are going up. I cannot just rely on petrol. Full electric vehicle with long enough range is too goddamn expensive. What is the only solution? Hybrid. So hybrid craze is going on. So that's the good thing. So these two things are pushing a lot of energy, money, investments into ICE engines. Now, right now, a lot of new ideas are coming into the market. For example, this is Scotch Yoke engine system. This puppy is supposed to be released to a Chinese car, EV car, as a range extender by 2025, meaning this year. This puppy's constant velocity engine. I will be unveiling this puppy in 2025 Expo. That would be a few days from now. I'm going there tomorrow. So if this thing works, that is also another option. Then you have twin rod Avenger engine, this puppy. This is drone engine only. At best, I can see this running on a basically motorcycle, but it's not anything other than that. But it's just for drone, this is short of take money. It's like, why won't you use cheap drones? Well, here's the, even if you have a cheap engine, if it's vibrating the hell out of it, that means your optical reconnaissance would be compromised. Or you have to have way too much electronics, way too much gimbaling just to remove that vibrations. I can take the same package, same eye in the sky, so to say, package, and I can put in this engine rather than one single piston engine. This will give me much smoother operation, much higher resolution. Now, does that matter? Yes, that's American philosophy. America does not like the idea of saturation bombardment. They're like precise. So again, for them, it's like shut up, take money. That's there. And then you have a rotary engine. Again, that's the master engine. They are single-handedly keeping this engine alive. So that's there. So what we are looking for? We are looking for 3 core variables. One is small as possible, meaning you should not even have to think about it, as small as possible. Efficient. We are not going to give you a 25-liter fuel tank. The fuel tank would be 1 liter or 2 liter. Again, that's a bit too facetious, but you get the point. It has to be small and low cost. It cannot be like this quantum mechanism technology and this and that, and it's like titanium and no. Variable valve timing, no. It has to be cheap, dirt cheap. So that's what we are looking forward to in future. So this was my presentation on basically range extender, the solution to our problems. Hopefully you guys have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.